Hello, this is Rajesh Khanal. Today I am here to present project on a topics of design, fabrication and testing of improved cooking stove. Then let's start. Don't you ever think that a meal cooked over a wood fire has more amazing taste than the same meal cooked over a LPG gas? Obviously. Then how was your experience of cooking meal over the wood fire? So there are many problems with intentional cooking stove. There is high heat loss, low thermal efficiency, high smoke emission, high consumption of wood, longer it takes longer heating time, and due to the incomplete combustion of. So I am here to present a design which helps to improve the thermal efficiency, get the less smoke. So what is the stove? Stove is the combination of heat generation from wood and that heat transferred to the cooking part. So normally, improved cooking stove is designed to consume less fuel, save cooking time, provide convenience in a cooking environment, and create the less smokeless environment. In context of Nepal, around 64% of Nepalese people use wood for the cooking purposes. Due to the smoky environment, 1.6 million people die every year because of the indoor pollution. So, our main goal of ICS is improve health, reduce environment impact, and increase the efficiency of cooking stove. Nepal government started to distribute ICS in the different districts to improve the household condition. There are different types of ICS which are being used in Nepal are mud brick, metallic, institutional, rocket stove, and beehive briquette stove. We have taken the some of the literature which are used during our project. First reference says that increase the number of secondary inlet around the combustion chamber promote the uniform velocity distribution. Reducing the primary inlet also increases the temperature of produces gas, which help in efficient combustion. Second reference says that using the 30 gap between the combustion chamber and outer cylinder provide the free movement of air through the holes, which help in fuel reduction for the secondary air. And third difference that the using skirt in the top of the combustion chamber increases the thermal efficiency up to 8%. The last difference says that there are two types of combustion takes place in uh, combustion chamber. First is surface combustion and second is gas combustion. The reaction between the oxygen and the wood surface is surface combustion. Solid particle and gaseous particle produced from the surface combustion. Gaseous particle again goes to combustion with the excess of oxygen. So we are primarily focused on gaseous combustion for the complete combustion process. Here are our objective. Our main objective to design, fabricate, and performance test and improve cooking stove. And the specific objective are to ensure the efficient condition, to ensure the efficient combustion by providing sufficient air supply through the secondary and primary inlet, and to ensure the proper air for the gas combustion through the secondary air, and to confine the heat flow uh, by providing the skirt around the pot, and to reduce the smoke emission by providing sufficient height for the combustion chamber. Here is our research method. First of all, we search on different website, we read books, and we gather the some of the information that are much helpful during our initial step of the project. So we select some parameter, uh, and we design the our cooking stove. So that design cooking stove is fabricated as per the design, and we have tested the cooking stove by WBT, and we calculate the performance parameter of our cooking stove. These are our purpose design at the initial time. So then we have selected this design, which has the high chance to improve the efficiency. Design dimensions are slowly based on the 17 cm single pot. So combustion chamber at the 13 cm diameter and 28 cm height for the 17 cm pot. And we have the air to wood inlet volumetric ratio is 4:1, and total height of the stove which comes out to 15 cm, and we provide the 2 cm gap between the combustion chamber and pot. This is the reference from which we take the dimension of combustion chamber. And this is the detailed drawing of our purpose ICS. Our cooking stove mainly focuses on secondary air for the gas combustion, which in which secondary air is entered from the lower base of the combustion chamber and goes up to the top of the combustion chamber. Secondary air is preheated before entering the combustion chamber. That reduces the heat loss. We also provide the 5 cm skirt to confine the heat around the pot. Then we fabricated our design at the Purvanchal campus Taran. We used the 1.2 mm mild steel, and the total weight of the cooking stove comes out to 5.3 kg. And these are the following component of our stoves. Then we have tested our cooking stove to calculate the required performance parameter. We use the WBT test, in which the cold start test, hot start test, and simmering test are carried out. We use salwood during the test, which has a moisture content of 11%. We use different types of wood, which have the dimension of 13 cm length, 3 cm width, and 2 cm height. We have taken the water of 27 degrees Celsius for the testing, and the boiling temperature of the water is found around 96 degrees Celsius, and we use the calorific value around 1800 kilojoule per kg, and we use 1.5 kg of water for the WB test. And these are the following performance parameter we have calculated from the testing. These are, and we use this formula to calculate the performance parameter. Then let's get into the result. We have done number of tests. So we have included three different types of tests in the presentation. Uh, with evaluating three different types of tests, we found that during the cool start phase, the average time was around 14 minutes, and during hot start phase, the average time was around 11 minutes. The thermal efficiency during the cold start phase is around 22 degrees Celsius, and on the hot phase, the thermal efficiency around 33 degrees Celsius, and during the simmering phase, thermal efficiency is around 26 degrees Celsius. Specific fuel consumption is also calculated, and the specific fuel consumption during the cold start phase is greater than hot start phase due to the cold ignition of stove, and the around 97 gram per liter is found during the cold start phase, and burning rate of the stove is around 11 gram per minute during the cold start phase, and the hot start phase at around 10 gram per minute. Also, the burning rate during the cold start phase is higher than hot start phase due to the cold ignition to heat up the cold stove. The firepower is also calculated, so it is found about 3.2 kilowatt for the cold start phase and 3 kilowatt for the hot start phase, and the 3.86 kilowatt for the simmering phase. So it is the graph during the process of boiling. The cold start phase had a curved line due to the cold ignition, but the hot start phase has straight line, and the left is the simmering test. So to our conclusion, we have found that our cooking stove has around 27 degrees Celsius, which is satisfactory by comparing the other cooking stove. And we have found that other cooking stove have around 22 to 25 degrees Celsius. And we have used the reference of this cooking stove, which used the 10 cm wall mud thickness, and which was found as 30 degrees Celsius due to the big thickness. So our cooking stove is satisfactory by comparing the other available stove. There are other works that can be done on our cooking stove are CFD analysis of our model, use of insulation of suitable material around the outer wall to reduce the heat loss, and the installation of air blocker or air maximizer in the inlet of secondary wall. And these are the differences of our project. And thank you everyone.